open push button and feed terminal number 2 in our coil, our 24 volt coil, and come out of terminal number 7 back to our power supply. Okay, so really we've just connected up our low voltage side of things. Okay, now we want to be able to deal with the 120 volt side. Okay, well, I need to bring 120 to my armature, and in this case I'm going to use my common number 8. Okay, and I want to be able to feed to energize, let's energize light number 2 while this is de-energized. So what we're going to do is we're going to come out of terminal number 6 and we're going to feed light 2. So between 8 and 6 we should have a normally open contact. Okay, and then we come from, I'm going to use I guess I can use a blue color here. I'm going to come out of number 5, which should be normally closed, to that light there, and then we're going to come back to our identified to feed both 120 volt loads that do require an identified conductor. All right, so now basically when I energize my circuit, I should have one light on, one light energized, the other one de-energized, and when I hit the normally open push button, they should reverse. The energized one will be de-energized and the de-energized one will energize. Let's see if that works. Okay, so right now we have our red light is energized and our blue light is de-energized. When I hit this button, they should switch positions. The funny thing is, if I do this fast enough and I make a certain sound, like wee you, wee you, wee you, wee you, it's almost like the cops are coming after you. Just have to make things interesting. Okay, so I'm just going to de-energize this for a second. So what I've done on the 120 volt side, I've fed power into the common of one armature, and I'm actually simultaneously using both the normally open and the normally closed. So terminal number 5 is my normally closed that went to red light from common number 8, and normally open from number 8 went to blue. So when I had no coil activated, I had a path on my 120 volt side from 8 to 5 to red light through my identified all the way back. Then when I hit my normally open push button, my current then went through 8. After my coil was activated, my normally open of 6 became closed and my normally closed became open, de-energized my red light and energized blue light. Okay, you should be able to draw a schematic of that circuitry there. Okay, and that's your objective for procedure 1. Okay, next what we're going to do, and I just want to make sure I have my power supply off, we're going to do procedure 2, and again just going to de-energize or take my circuitry apart so we can start from scratch again. So there's no confusion, or a little bit less confusion anyway. All right, here we go. There we go. So I need you to draw a schematic symbol for procedure 2. And procedure 2 says we want to control through a 24 volt circuit to control a 120 volt load, that it can be turned on from two different locations. The load must remain energized after the button is released, and we have a single push button will de-energize the control circuit and therefore de-energize the load. All right, so we're going to have a total of 3 switches. 2 switches will energize the light. One and a third switch will de-energize the light. Okay, and I'm going to use my blue light that we're going to use. Okay, and once we energize the light, we want it to stay on until we actually de-energize. Okay, so what we're going to do is we're going to actually use 2 normally open push buttons to be our 2 switches that energize the light, and we will use 1 normally closed push button to de-energize the light by de-energizing our coil. Okay, so I'm going to take power into my normally closed push button, put that normally closed push button in series with normally open push button. I'm going to make that normally open push button in parallel with the other, or the second normally open push button. Okay. So now I have my normally closed in series with the beginning of each one of my 2 normally closed, my normally open push buttons. I'm going to put my 2 normally open push buttons in parallel with each other. And then from there, I'm going to make a connection to terminal number 2 of my coil. Then from terminal number 7, my other coil connection, all the way back to power supply. Okay, one more thing I need to do is I need to be able to put a holding contact in place, so when I release either one of these buttons, the light will remain on because my coil remains energized and I have a pathway to feed the coil. Okay, so I am going to make a connection from basically let's do the front side of both of my normally open push buttons and be connected to coil common connection number 1. And the other side of my normally open push buttons, being this side, will be connected to a normally open contact on my relay, which if I'm using 1 as a common, 3 is a normally open contact. So this becomes my holding contact, my blue terminals for my switches. So that completes our low voltage side. Then what we want to do on the line voltage side is we want to take a power supply, and because I'm using the common number 1 for my holding contact, I'm going to use common connection number 8, feed 120 ungrounded into number 8. Then I'm going to come out of the normally open contact side, which should be number 6, and feed my light identified from my light all the way back to my power supply. So in this case here, I should be able to, either one of my normally open contacts should activate my 24 volt relay coil. I have my holding contact in place, so when I release either one of those buttons, I continue to have current going to my coil through the holding contact, and my light remains energized. And it's not until I activate my normally closed push button that I break the current going to my coil. It will de-energize my coil, and then my normally open, my normally open contacts will now close, de-energizing my coil, de-energizing my light. Let's try this and see how it works. Okay, so I've activated power. My light is still de-energized. I'm going to hit switch number 1, normally open. My light is activated. I let go. My holding contact is activated because as soon as I hit the button, activated current going to my coil. My coil closed contacts 1 to 3, and it allows current to go through 1 and 3 to keep my coil activated. I can now de-energize the light by hitting my normally closed contact or push button. There we go. Activate my second normally open push button. Let go. Holding contact holds it in place. I activate normally closed push button. Deactivate my light. Okay. So I have three 24-volt switches, 2 normally open push buttons on the 24-volt side. Either one of these will activate my 120-volt light through my 24-volt coil, and my normally closed push button